Hi guys, this is a lesson on section 3.7 in your textbook. We're going to be talking about the equations of lines. Feel free to stop the video when necessary and re-watch portions that you didn't understand the first time. Let's get started. The first thing we're going to talk about is how to find the slope of a line. This is something you should have learned in Algebra 1. We could find the slope of a line two ways. The first way is if it was on a graph, we could always count the rise over the run. So we're going to count how much we're going up and down, how many spaces, and then the run is how many we're going either to the left or to the right. There's also a formula for slope, and on top is going to go y2 minus y1. On the bottom, we're going to subtract x2 minus x1. I remember this because rise rhymes with y's, so I'm going to put the y's on top, and the x's are going to go on the bottom. So first example, I just want you to find the slope of this line. Before we start finding anything, we're going to label our points x1, y1, and x2, y2. And then we're going to go ahead and put those numbers into our formula. So we're going to do y2 minus y1, or 9 minus 3, over x2 minus x1, 12 minus 8. Go ahead and subtract on the top. 9 minus 3 gives us 6. 12 minus 8 gives us 4. Always a good idea to simplify when we're working with slopes in geometry. So that would simplify to the slope of 3 over 2. That means we're going up 3 and over 2 spaces to the right to get to the next point on our graph. It's going to be a positive sloping line. Let's practice it again. Before we start plugging in numbers into our formula, we're going to label them x1, y1, x2, y2. And then plugging it in, we have y2 minus y1 over x2 minus x1. When we do our subtraction here, 9 minus 9 gives us 0 over 3 minus 6 is going to be a negative 3. We have a 0 in the denominator, which means the slope of this line is 0. Zero sloping lines, if you were looking at them on a graph, would be a horizontal line. Zero sloping lines are going to be horizontal lines. They have no slope. It's a zero slope. It's a flat line. And the last one that we're going to do together, again, label x1, y1, x2, y2. We're going to subtract 2 minus a negative 7 over 5 minus 5. 2 minus a negative 7 is going to give us 9 in the numerator. 5 minus 5 gives us 0 in the denominator. Anytime we have a 0 in the denominator, that's going to be an undefined slope. An undefined slope, if we were looking at it on a graph, would be a graph that is a vertical line. So this is going to be a vertical line through x equals 5. You're going to try the next 3 problems on your own, D, E, and F. Make sure you label the points, plug them correctly into the slope formula, and simplify when necessary. We'll check them in class. We're going to talk about the equation of a line now. The equation of a line you guys are probably most familiar with is y equals mx plus b. That's the equation of a line in slope-intercept form. The m variable, that is the slope of our line, that tells us how steep this line is going to be and whether it's going up at a positive slope or going down using a negative slope. The b variable, that's your y-intercept. That's going to be where this graph crosses the y-axis. So the b is your y-intercept. That's where the graph crosses the y-axis. Here's our first example. We have a for 4x minus y equals 16. In order to figure out what your slope and your y-intercept are, you need to solve this equation and get y by itself. So let's start by moving the 4x to the other side. we get negative y is equal to negative 4x plus 16. Finally, we need to get rid of that negative sign in front of the y, which means we're dividing everything by a negative 1. Y equals 4x minus 16. In this example, our slope is always the number in front of your x. Slope is going to be 4, or a slope of 4 over 1. We go up 4 and over 1 every time we need to get to a new point. Our y-intercept is going to be down at negative 16. Don't forget that negative sign. Question B, again, we want to find the slope and the y-intercept. So let's get the y by itself. I'm going to minus 2x from both sides. We end up with 3y is equal to a negative 2x plus 8. I'm going to divide every piece of this equation by 3. So y equals a negative 2/3 x plus 8 over 3. This again means the slope, the number before the x, is negative 2/3. We're going to go down 2 and over to the right 3 to get to our next point. And our y-intercept is at 8/3. That's where it's crossing the y-axis. Last one we're going to do together, y minus 6x equals 5. Let's solve this for y. I'm going to add 6x to both sides. Y is equal to 5 plus 6x. Notice you could have also written that as y equals 6x plus 5. The commutative property says the order does not matter. Our facts are still the same. Your slope is always the number before the x. That's going to be a 6. Sometimes when you're graphing that, 6 over 1 would be helpful because you know you're going to go up 6 and over to the right 1. The b is the other number in this equation. That's going to be a positive 5. We cross our y-axis at 5. D, E, and F are problems you're going to do on your own. Make sure you're solving for y and telling me what the slope and the y-intercept are. If you need to simplify, make sure you do that, and be careful about negatives. We'll check these in class. One last thing to talk about today is the difference between parallel lines and perpendicular lines. We know what parallel lines look like. They're going to be lines on a graph that never intersect. So the two lines that I just drew are parallel. They never intersect. The other thing we know about parallel lines is they have the same slope. Parallel lines have the exact same slope. So for example, if my slope was 5 and your slope was parallel to me, your slope would also be 5. The opposite of that is going to be perpendicular lines. We know perpendicular lines are lines that cross at right angles. So now we need to talk about their slopes. Their slopes are going to be opposite reciprocal slopes. Slopes are going to be opposite reciprocals. I'll explain what that means. Here's your first example. If my slope was 2/3, reciprocal means flip it upside down. So that becomes 3 over 2. The opposite means change your sign. So we get a negative 3 over 2. Let's do one more. If I gave you a slope of 5, this is where it would be beneficial to write it as 5 over 1. Perpendicular to that means flip it upside down to 1 over 5. And we're going to change the sign. It becomes a negative. So perpendicular lines have opposite reciprocal slopes. Parallel lines have the exact same slope. So that number before the x is going to be the same. So we need to determine if these two lines are parallel, perpendicular, or neither. First step is make sure both equations are solved for y. They both are. Then we need to look at the slopes, just the number before the x. The slope of the first line is 4. The slope of the second line is 4. Since they are both the same, that means our lines are parallel. Remember this symbol for parallel is the two lines. Looks like two L's or two straight vertical lines next to each other. All right, the next question, again, we need to get both equations solved for y. So starting with the first one, we have 13y minus x equals 7. I'm going to move the x to the other side. We get 13y is equal to x plus 7. Finally, we're going to divide everything by 13. Y is equal to 1 over 13x plus 7 over 13. If we take a look at the other equation, 7 minus y over 2 equals x. I want to solve for y again here, so I'm going to minus 7 from both sides. We have negative y over 2 is equal to x minus 7. And finally, I'm going to multiply everything in this equation by that negative 2 to get them to cancel. So we get y is equal to a negative 2x plus 14. The only numbers I really am interested in are the slopes, the numbers in front of the x. I have a negative 2 and a 1 over 13. There is no relationship with those numbers, so these two lines are neither parallel nor perpendicular. Last one we're going to do together. We want to solve both equations for y. Equation number 1 is already solved for y. We need to do a little bit of work for equation number 2. In order to get the fraction 4/3 to cancel out, we need to multiply by its reciprocal, 3 over 4. We're going to multiply everything by 3 over 4. We cancel on the left side, and we get y is equal to 3 over 4x minus 3/4. Let's take a look at these slopes. The slope in equation 1 is a negative 4/3. The slope in equation 2 is a positive 3 over 4. These two slopes are going to be opposite reciprocals. They've been flipped upside down. The slope of the first line was negative. The slope of the second line is positive, which means these two lines are perpendicular. And finally, you have D, E, and F to try on your own. Make sure you solve each of the equations for y in order to determine whether the lines are parallel, perpendicular, or neither. We'll go over these in class as well.